Our intervals, C major, A minor, and related modes. This time looking at the E Phrygian mode, focusing on centering around measuring from the E note located on the 5th string down from the top of the guitar, fret number 5. This is part number 1. One of our major objectives is to orientate all of our resources in the same direction, making them as easy on the eyes as possible from the perspective of the player of the guitar, who is of course located behind the guitar. Therefore, for example, my guitar is going to look like I'm playing left-handed, but no, we just flipped the guitar around to mirror your perspective from behind your guitar, as though you were playing into a mirror. And as you're playing into this mirror, you might be thinking, hey, where did my diamond ring go? It's gone. It's gone. It's like, no, this is not an actual mirror. Bless your heart. It's like a mirror. We flipped it around like a mirror. That's the idea. Similarly, with our Excel worksheet representing the fretboard, this is representing the low or heavy string, the one closest to the ceiling. If we go top to bottom, left to right, it is as though we took the guitar and just imprinted those strings on the screen. We're now going to be looking at the Phrygian mode and looking at the intervals related to the Phrygian mode down on the string at the bottom, the B string. And let's get a quick recap of the general project in terms of why we are doing this, what we're trying to pull from it, as we're now going to a new string down here that we're measuring from, and measuring basically from a new perspective, that being the Phrygian mode. So how does it relate to all the other modes? If we scroll up to the top, we're looking at the major scale, otherwise known as the Ionian mode, and we're looking at the normal shape that I think is most common to most people, and just walking through that shape, looking at it from each perspective of each note within that shape, which we want to do not just by the perspective of the actual note, meaning I don't really want to see, well, let me measure it from the A note and so on and so forth. I want to measure it from the position that I'm looking at, because the positions are relative and movable. The shapes are relative and movable. So that's going to be the idea when we're starting on the C. Then I'm measuring from the C notes, and I'm going to be looking at the intervals around it from that perspective, giving us the shapes. Now, I also not only want to do that from one C note, which means that I would be in this case, the Ionian mode, but each string, it would be useful to measure from, because that will allow me to build the shape from any of those basic root notes. It's also going to help me to build basically the chord constructions. So that's why we want to go through basically the full shape, even though the full shape goes through the entire scales basically 2 times if we're looking at the shape. And then we can move that shape and the relative positions is the general idea. Now, this is the most common shape number 1. If you had it on a pentatonic shape, it would be like, sound like that. If you had the 7-note shape, it would sound like that. But if you play it like that, then you're playing from the A here, which would be meaning you're playing in the minor. All the notes are going to be the same for the relative modes. If I went from C to C, then I can imagine that basically as the major. Noting that the major mode is no different than the other modes from a modal construction standpoint. They're all, it's like saying, it's like physics and you're trying to measure from this point to another point or something. It's like, whose perspective is correct? They're both correct. It's just, where are you looking from? What's the perspective that you're looking from? Similarly here, all these modes are the same, notes in them, but the intervals will differ depending on the perspective that we're basically looking at. So the idea would be that we can build this shape multiple ways. We can learn the shape, and I can just say, okay, this shape happens to be a C. There's the C within this shape. Here's the minor note. I can start to memorize the relative positions within the shape for each of the modes. If I center around those modes, that's a great way to do it. I can combine that with the concept of a caged construction, learning the open position shapes, moving those shapes up the fretboard, labeling my chord construction based on those open position shapes. That's a great way to learn it. We can learn it with a formula, which is the whole, half, whole, half. If you've seen the piano layout, you can do that. But we would like to do that not just from the major position, which is what most people know. If you try to ask someone that formula from a different position, they often won't be able to do it. It's kind of like counting or saying the alphabet. If I say the alphabet A, B, C, D, E, F, G, A, B, right? What if I say start counting the alphabet from an X or something? You might find yourself having to sing the alphabet from some place other than X in order to keep going. You can't go just from that spot, and you certainly might not be able to go backwards from any given point in the alphabet because you haven't practiced that and you learned it linearly. So what we want to do is possibly try to break that up so that I can start at any point, which is basically what the modes are doing, right? I'm going to start from a different point. It's the same pattern as though the alphabet was going around in a circle, but I'm going to start from the center of it, right? And then possibly do it backwards, which would be useful. And these things seem basic. It's kind of like counting backwards or saying the alphabet backwards. When you hear people tell you to do that, you feel like they're disparaging you, right? Like, of course I can do that. It's the ABCs backwards. That's not hard, but it is hard because we don't practice doing it. You're not used to doing that, right? No one really does that. So that's kind of what we want to do, is break the shape up and be able to see it from all the, different kind of angles within it. And the way we're going to look at it here, then the third way, is by the interval construction. So we want to look at the intervals. I want to take each of these notes and then be able to rebuild the same shape with the different intervals constructions, which means we're basically building all of the related modes. If we can do that in one shape or in one place, we should be able to take those concepts and build them the same things, all of the other modes that are related to another major scale, right? So, and I use the major scale as the reference key, as our point of reference. So whatever, if there's only, A, B, C, D, E, F, G, and the sharps and flats, right? So there's 12 notes. So we can have 12 major scales. And then all of if you categorize this in your mind, that just simply means that all of the modes related to all of those major scales will be in those categories. That's why it's useful to categorize it that way. Otherwise, you'd be memorizing 12 scales times 7, right? And that's going to be a lot that's too much to try to pack in your mind. So what do? We say, okay, I'm learning like the major scale. I'm going to use it as the key reference. There's 12 major scales because there's 12 notes, right? And then I'm going to pack into it all of the related modes that have all the same notes. They're just starting from a different position is going to be basically the general idea. And then if I can learn the shapes of those, I should be able to reconstruct them in those three ways: by shape, by formula, and by interval. All right, so now we're going to be looking at the Phrygian mode. So remember, the next idea would be that why is this useful? Well, if I want to make songs, if I want to just noodle around, if I want to do anything, then I have to know the notes in the chord. Notes in the scale is going to be necessary. Once I know the notes in the scale, I want to then build chords. When I build chords, the base chord construction is a triad chord, and that means that I need to know particularly the third. Is the third a major third, or is the third going to be a minor third? Most people memorize that in relation to the major scale by saying, well, I happen to know that the 1, 4, 5 are major, and the 2, 3, and 6 are minor, and then the 7 is that crazy Locrian, which is like a minor with a flat fifth. So that's what most people start to learn, and we start to just say, okay, now I just need to locate those notes, and I can say, is it the 1, 4, 5, then build a major chord? Is it the 2, 3, and 6, and build a minor chord? The problem with that is that it limits us to the major scale, because if I then go to like the Dorian mode, or in this case, we're going to the Phrygian mode, now it's going to be more difficult if I start from the Phrygian and then I'm trying to say, okay, they're all the same notes, but if I don't see it from the perspective of the major scale, how do I know which note I can build a major chord and a minor chord from? Becomes a little bit more difficult. But if we label the modes in relation to the major scale, which is just a convention, that might help us out a little bit, right? So if I say the Phrygian mode is absolute mode number 3, as it relates to the major scale, that means it's equivalent to starting on the third of the major, and I know that the third has a minor chord construction. I can kind of start to figure that out. And if I'm starting on the third as it relates to the major, then the second of the Phrygian is equivalent to the fourth of the related major, which means it's going to have a major chord construction. So we can kind of try to memorize it in such a way that I can play in something other than C major and still be able to determine, do I have a major chord construction and a minor chord construction? Now, if we do this by learning the modes, then we not only get the major or minor chord constructions, but we also can go beyond just the 1, 3, 5 to the 7, 9, 11, and 13, the 9, 11, and 13 being equivalent to the evens that we skipped for our purposes, the 2, 4, and 6. So in other words, I would like to be able to build not just a triad, but more chords that have the other notes in the scale. And I need to know then when am I going to have those notes fit? Is it going to be a major 7 or a minor 7, a major 9 or a minor 9, a major 11 or a minor 11? The only way to know that really is to know the related modes, and that's kind of what we're working on at this point in time. So that's going to be the general idea. So the general concept is what are the intervals for the major scale? Then we learn the related minor scale, the Aeolian, and then we compare all other modes from an interval standpoint to its related major and minor, all other modes only having one interval difference from their related major or minor. So for example, the major scale here has a 0 note away perfect first, a 2 note away major second, a 4 note away major third, a 5 note away perfect fourth, a 7 note away perfect fifth, a 9 note away major sixth, and 11 note away major 7. So we're now going to go to a minor mode. So you would expect the minor mode, the main minor, which is the Aeolian, minor scale, minor mode, Aeolian mode, the sixth of the major, the sixth mode, should have all of the majors flipped or flatted to a minor, stepping one step back, and then all the perfects remaining the same, which is basically what happens, except for some reason, the second is still a major second. So the main minor, the minor scale, the sixth mode, Aeolian mode, another word for the main minor, minor scale, has same intervals as the major, except all the major components are flattened, except for that major second, which is not. We're now looking at the Phrygian, which is a minor mode defined by the fact that it has a minor third in its construction, which makes it a minor mode in essence. And so now we can compare the Phrygian to the Aeolian. We compare the Phrygian to the main minor, which is the Aeolian, and it's only going to have one interval difference than the main minor, and that happens to be the second. So that 2 note away minor second is flattened. So you could still compare it to the C, our key, because you could say, well, you might say, so you can look at the Phrygian two different ways, mainly, right? Most people, I think, would compare it to the minor and say the Phrygian is closest to the minor. It's going to have all the same intervals as the minor scale, except it's going to have a flattened second, meaning it's more minor than the main minor. Or you can compare it to the major scale, which is our main key, and say, well, the Phrygian is a minor, therefore it's just going to be it's going to flatten all of the majors to a minor, and the perfects are generally going to be kept the same, and the Phrygian even flattens the second, whereas the Aeolian doesn't. So my story is always like this. You've got the major scale, which is kind of like the cool one, and then you got the minors, which are a little bit more darker, right? They're coming in with a little bit more dark kind of feel, and then you've got the Aeolian is like the main minor, but then like the Phrygian is like even more minor, like they're even more minor. They went almost a little bit too far. People are like, you went a little too far by flattening the second, because that's kind of a tension-y sound. That sounds a little crazy. You're a little out of the whack. And then beyond that, you've got the Locrian, which went totally crazy and flattened the second. So it's like the Phrygian, but then it flattened the second. And then you've got the Dorian, which is like, dude, I don't want to go that minor, and it's closer to the major because it has another major, a major 6 to it. So when we look at the minors, you've got the main minor, which is actually kind of in the middle, the Phrygian, which is even more minor than the main minor, the Dorian, closer to the major scale with a major interval, and then the Locrian, that's not even minor anymore because it went so crazy by flattening the 5. All right, that said, we're going down to the Phrygian here. And we're going to be measuring around this one. Now, just one more note on you might be saying, dude, this is totally redundant. We've done this like a million times, but we haven't, because we're measuring on different strings, right? We're measuring on, so notice that the fact that we're measuring in the middle of the guitar means that the intervals will be movable up and down the guitar. That's great. Those shapes would be redundant if we go up and down the guitar. But when we go to another string on the guitar, then we're going to have new components every time we go to a new string. Because, for example, if I was on this E up here that we did before, I can't go above it, right? Because there's only one string above it, unless I think about going around the top of the guitar, which you can do if you take into account that the top E string repeats on the bottom. But most people don't think of it that way. That means if I'm looking at this E, I can only look at the shapes above it, that's one string above it. And then I have the ability to look for shapes below it, 1, 2, 3, 4, 5 strings below it, right? But now that I'm on this bottom bit of the guitar, now I've got all these strings above it. So now I can measure the shapes above it that are 1, 2, 3, 4 strings up. And then below it, I can only go down one string. I can't go down as far in this direction. Now, that wouldn't be as much of a problem. Even that wouldn't be as much of a problem, because all the shapes would be the same no matter which string we start on in general, if we didn't have the fault line. But this fault line shifts the tectonic plate to the right. So that also throws things off. So what we need to do then is look at all of the intervals on each of the strings, and it will then be movable from left to right, but it won't necessarily be as movable from top to bottom, or not exactly the same, because there'll be differences in terms of how far up, how far down you can go, and there'll be differences in terms of this fault line throwing the shapes off whenever you cross the fault line. Now, it's also useful, a lot of people like me, for example, haven't spent as much time measuring from the bottom of the guitar. Some people do, because a lot of people count, when they talk about the guitar, they actually count from the bottom of the guitar as like the first string or whatever. And I think that's in part because the tablature oftentimes flips the guitar upside down. It's because it's as though you're looking at the guitar. It's not mirrored as though I'm left-handed, but it would be flipped around. So you're looking at the guitar with the little string on top, which would naturally lead you to start to go from top to bottom if you're reading like a normal English person, or, Western person that reads from left to right, top to bottom, So you might actually have learned the bottom string first. It's also quite useful to learn from the bottom of the guitar when you're playing in a band, especially with a bass player and whatnot that might be playing the lower registers, and therefore you want to fill the space on the higher registers. So it might be more useful to learn this higher space. But I think most people, what they do is when they learn the top two strings, all the notes on the top two strings, right? And then what we do is we possibly build power chords, eliminating the third, just playing the fifth, because I can add a fifth with a nice easy power chord shape, which looks like that, on every note, on any string except for one, which is going to be the Locrian one, right? Which has a flat fifth. So I learned that, and then we learned the caged system, if not the entire caged system, the major two bar chords of the caged system, which means that if I can learn which notes are going to be major and minor, the 1, 4, 5 major, related to the, when you say related to the C or to the major scale, the 2, 3, 6 minor, then I can build what we would call from a caged system an E major shape or an E minor shape, meaning taking these shapes, E minor, E major, turning them into a bar, right? And then moving those up the guitar on the top strings to be able to play any of the strings in either a major or a minor. And then on the A string, we convert each of those from an A or an A minor to the bar chord, and we can move, and we can then play a bar chord from any of these strings. That means that if I learn the notes on the top two strings, and I can identify which of those root notes are going to be major or minor in my chord construction, then I can build a major or minor chord off any of the notes from the top two strings. That's great. But then that means that we're not really thinking about, what if I'm thinking about this is my root note down here? I'm not really thinking about how am I building a chord off of this root note down here. I might start to see that my bar chord can be broken down into the bottom half of the bar chord, which is basically its own chord if it has the same three notes. But what I'd like to do is more formally be able to look at a note down here and construct a three-note chord from it, at least, as easily as I can be looking at the bar chords up top, which I can easily do if I start to better recognize the intervals. And so that's going to be the idea. Also, of course, if I measure down here, I'm right next to the fault line. So I'm going to be more cognizant of what that fault line does to the shapes down here. Instead of just learning, like if you learn a shape that consists of all of the strings on the guitar, you might think that that's not too much information to pack into your mind, but it is really, because there's only three notes in the shape, even though you're playing five notes, because some of those notes are going to be repetitive if you're playing a normal three-note triad bar chord. So you probably, a lot of people don't know what notes they're actually playing. They just know it's a bar chord, and they know the root, and they know the shape that makes a major or minor bar chord. But what we'd like to do is be able to analyze what's actually happening on this bottom half of the guitar, and then you can do a lot more variations on the bar chord, right? So it's actually a lot of information's packed into those bar chords because you're using all six strings. Okay, that's enough of an intro here. So let's get into it. Let's try a joke before I go, because that was a long intro. This is I feel like I need to trim this one down here, but here's what I got in the raw material. You know, the term class action lawsuit sounds like it should be something cool, even though it's like kind of a boring thing, like a class action lawsuit. It almost sounds like a movie or something, like where you have Daredevil. It's a Daredevil movie or something where you have like Matt Murdock is a teacher of a law class, putting together a lawsuit on behalf of the class. But when things get corrupt, he breaks into action. That's why it's the class action lawsuit, right? It's a classy, or possibly it's a classy action lawsuit drama or something, right? It sounds like it should be something interesting, even though it's not. You know, the scariest Hollywood Halloween costume to the mainstream of sewage media these days, the scariest costume you could put together is a man dressed in a Constitution as a suit. They've got a Constitution suit on. Why? Because that's right, it's a lawsuit. It's a lawsuit, you sons of lions, sons of dang harpies are fading back in horror. Why? Because you're wearing your lawsuit. And the mainstream of media liars are like, no. It's like the Constitution suit is coming. They're being drowned in water, just cleansing them in water, but there's nothing left after the water cleanses them because they've been rotted out to the core, man. Okay. Anyway, let's get back to it. All right, so we're going to start with the perfect first. Once again, the perfect first, of course, is the same. We're looking at octaves, or just basically the same note. I'm not going to get too much into basically the octaves, but the idea here is going to be that if we take each of the strings, let's go from 1 to 12 in terms of the frets, and wrapped it around in a circle, we would have all 12 notes in a circle. And if we go around the circle all 12 steps, we would go one lap around the circle. Therefore, there's no real inverse distance to the octave, because if I go counterclockwise or clockwise around the circle, I will then end up at the same point I started with. So that's going to be the idea here. So we're going to go 12 steps, so I don't have to look for the inverse distance. In other words, normally when I go above the string, I have to look for the inverse distance, but this is kind of the exception because there is no inverse distance if you're looking at 12. By the way, the other exception is if you go exactly halfway around the circle, which is a sixth note away, which you might call like a flat fifth or an augmented fourth. Also, you're in that weird situation where you can go either way and there is no real inverse. So we have those two situations here. So also just realize that right above here is right when we cross the fault line. So we have the fault line right at our head, at the top of our head. There's the fault line. So that means that we have to take into account that difference, because this whole tectonic plate shifted to the right a long time ago, like back in creation. It was back in like the creation of the guitar. Somehow this whole tectonic plate shifted to the right. And so now we just have to deal with it, man. That's what happens. Nature, dude, nature. All right. So if we go up one string, we're going to be out here. So we're looking for a 12 note away. So if I go up one string, now remember, normally we've been going down, and whenever we go down, if I like went down, I'd have to go, instead of 5 note distance between these two, I had to go this way to get to the 5 note distance. Right now I'm going up across the fault line, which I'm not used to doing as much, right? So when normally the 5 note distance would be right above it, but because of the difference in the tuning, the 5 note distance is this way. So I'm going to call this -5 going out to that B, -5, -4, -3, -2, -1, and then 0 or 12 back to the octave, or in this case, the same note. So if I was here, then we're going to practice going up over the fault line, which again, it's just like the alphabet, where you're thinking, oh, I can count it forward and backwards just the same. Only a stupid person can't count the alphabet backward. No, most people can't count the alphabet backwards. You're not stupid if you can't do that. So it's gonna be 5. So we have to do the opposite, right? I know how to go across the fault line when I go this way, but what about if I go up across? Well, then I have to go back here. It's gonna be 5, and then 4, 3, 2, 1, 0, or octave. So we're gonna be out here, fret 9. So same. All right, so that means that if I go up one string and cross the fault line, the octave is going to be 4 frets forward. But that's the only time I would cross the fault line. If I was down here, it would be here. I wouldn't cross the fault line if I was on this continent. And if I was on this continent up top, I wouldn't cross the fault line. So the rule is usually if I go up one string, then the octave is going to be 5 frets forward. It's only when I cross the fault line, which would only happen on the B string, in which case, if I go up one string and cross the fault line, the octave is only 4 frets forward. All right, let's go up 2 strings and cross the fault line. So we go up 2 strings and cross the fault line. The octave is going to be over here. Let's count it out. So again, normally if I went this way, I'd have to go this way to go a distance of 5. That means if I start down here, I've got to go back. I'm going to call that -5 distance, and then up. Now we're normal. The fault line is no longer here, so -5, -10, and then this way it's going to go more -11 and 12. So let's count it out from here. So I'm going to say it's going to be this E. So I'm going to say -5, -10, and then 11 and 12. So boom, boom. So. Wait, is that right? Yeah. So there we have that one, and that means that if I go up 2 strings and cross the fault line, then the octave is going to be 1, 2, 3 frets back. But normally I wouldn't cross the fault line, or I would not cross the fault line if I started from the G or the D string, right? Because then I could still go up 2 strings and not cross the fault line. So if I was on like this E and I went up 2 strings, I would be back here. So the rule, and this is the shape that you probably recognize clearly if you were starting from this E and then trying to find the octave 2 strings down. That's often the most common octave. Less common to start on the bottom E and then visualize it this way. Same kind of thing of reversing the vision, like counting backwards, saying the alphabet backwards. And then we added another wrinkle into that problem, in that now this is crossing the fault line. So once again, if I was going from this E down, I'm possibly getting better at being able to compensate for the fault line, noting that instead of reaching to this one, now I'd have to reach up here for the octave but I'm most likely not as good at imagining myself down here and measuring back up, going across the fault line this way, even though it's the same shape, right? So that means that if I go down 2 strings, the octave is going to be 2 frets forward. And I'm sorry, if I go up 2 strings, the octave is going to be 2 frets back unless I cross the fault line, which would happen on the bottom 2 strings, the B and the E string, in which case if I go up 2 strings and cross the fault line, the octave is going to be 3 frets back. All right, let's go up another string and across the fault line. So we're going 3 strings up and across the fault line. So I'm looking for a 12-note distance. So I'm going to say this is going to be, once again, -5 diagonal this way, and then 10 straight above, 10 straight, 15 straight above, only 12 notes in the musical alphabet. So we're going to say 15 minus 12 is -3, -2, 1, 0. So I can count that this way. I can say, all right, this is going to be -5, -10, wait a sec. If I'm on this one, -5, -10, -15, and then 15 minus 12 is -3, and then -3, 2, 1, 0. So it's going to be boom, boom. Okay, so that means that if I go up 3 strings and cross the fault line, the octave is going to be 2 frets forward. I wouldn't cross the fault line if I was starting on the G string, because I could still go up 3 strings. That's the only one where I could still go up 3 strings and not cross the fault line. So let's say I was here, for example, and I went up 3 strings. So I'm going to go it would be up to here. So now we're going to say, okay, if I go up 3 strings, then the octave would be 1, 2, 3 frets forward, unless I cross the fault line, which actually would happen more often than not, because it would happen on the bottom 2 strings. The only time I could go up 3 strings and not cross the fault line would be on the G, unless I consider going around the top of the guitar, which we're not really getting into at this point. So we're going to say, so if I go up 3 strings and cross the fault line, then the octave is going to be 1 fret forward in that case. All right, let's go up to the top one. Now notice when I go up to the top one here, we could say it's going to be 1, 2, 3, 4, 5 frets back, possibly right here. Now it might be easier now that we're on the bottom of the guitar to recognize that these 2 strings are the same in terms of pitch or you know the tone. So I could try to count down first and then apply that up top. So if I go down, there's no change in the fault, and there's no fault line between these 2. So I could just say 5 and then 4, 3, 2, 1, 0. And if this is the octave, it's going to be the same on the top string because they're the same notes. So again, that's kind of a trick that we're probably more used to doing at the top of the guitar, finding the note on this string and then seeing that it's the same at the bottom. At least I am. So, but we can apply that same technique, of course, on the bottom of the guitar because I'm closer to this bottom string. If I did count it up this way, though, it would be -5, -10, 15. I can bring that 15 down by 15 minus 12 is 3. 3 plus another 5 is 8. So 8, 9, 10, 11, 12. So that's kind of a long reach. I'm losing my voice out there. So you possibly, but the idea would be if I go up 1, 2, 3, 4 strings and cross the fault line, which I don't need to say, because if I go up 4 strings, I'm always going to cross the fault line unless I consider going around the top of the guitar, right? So if I go up 4 strings, I can say that I'm always going to cross the fault line, therefore I don't have to say that once I start to internalize that in my mind. Well, I went up 4 strings, which means I, of course, did cross the fault line, and that means that it's always going to be 1, 2, 3, 4, 5 frets back to get to the octave. All right, let's go down. If I go below it, now we're not crossing the fault line. We're just staying on the tectonic plate that is on the bottom, the small plate. So we can just say, all right, that's just going to be 5, 4, 3, 2, 1, 0, as we saw before. So we're just going to say this is going to be -5, 4, 3, 2, 1, 0. Here to the open. Same even note, or same octave even. So that's going to be that one. And so that means if I go down one string, the octave is going to be 5 frets back. Unless I cross the fault line, which would only happen on the G string. So if I was on the G string, then we could see that what happened, this note got pushed forward. So if I'm measuring from here, where I'm measuring to got pushed forward, making the distance less. So the rule would be, if I go down one string, the octave is going to be 5 frets back unless I cross the fault line, which would only happen on the G string, in which case, if I went down one string and crossed the fault line, the octave would only be 4 frets back. All right, so that's going to be that one. And then we'll go to the second, but let's do a quick joke first, and then we'll crank out the second. So it's an interesting story how we named our poodle. We named our poodle. All we did is we just basically put 2 and 2 together to name the poodle. And what did we get? We got, of course, Tutu. We named the poodle Tutu because we put 2 and 2 together. I don't really have a poodle, but you get, because we put 2 and, I put 2 and 2 together, and I was asked to put 2 and 2 together, and I could do that easy. What did I get? I get 22. Some people say you get 4 when you put 2 and 2 together, but no, that's only if you add 2 and 2. If you just put 2 and 2 together, clearly the result is 22. A lot of people get that wrong, just so you know. Man, they're getting worse. You're getting worse. You practice every day, and how is it you get worse? It's ridiculous. I don't know. I have a talent for it. Let's go to the next one. We're going to the second now. The second of the Phrygian, which we can also name as the fourth of the related major scale. Therefore, we know we're going to build basically a major triad from it, as well as a major. It's a major mode, which would be like the Lydian mode if we were building from this note. But we're just looking at it as the second, as it relates to the Phrygian being the 1, the E here, and it's going to have a distance of a 1 note away minor second. Now, the Phrygian is actually a fairly easy mode kind of to understand, because the difference between the Phrygian and the related main minor, the minor mode, minor scale, is right on the second interval, which is as soon as you can be. You can't have the first interval not be a perfect first, right? So it's right on the second one, where you have the second is a flat second, which means it's right next to it, right? So, and that's what gives you that tensiony sound. So that's the thing that's going to be differentiating the Phrygian, that interval, from the main minor, which still has a major second. So that means that if I wanted to change this shape, like if I learned this shape, and I'm like, oh, this is the C major shape, which I might call in a caged system, it would be a G-shaped C major chord shape that I build the pentatonic and then the major scale around. You might see it that way. If I say this is like that shape, and it has all the related modes, if I look at all the other modes as the starting point, then I can say, well, if I make this the tonic, which we're doing, which is the E is now the tonic in that same shape, that would be the Phrygian mode. It would be the E Phrygian mode. What if I wanted to convert from the E Phrygian, which is a minor mode, to simply the E minor? Well, then all we'd have to do is take that second, which has been flattened, and move it out, right? So if I want to convert this, I could learn the whole other shape for the F, right? I could say, well, where's the F? Well, maybe I could start playing like this shape right here. If I started this same shape from the F, I would be playing the F minor, right? But what if I just want to convert this shape where I'm already at to an F minor? Well, if I know that this shape is equivalent to the F Phrygian, I could just take all of the I'm sorry, not the F. I was looking at the E. The E shape would be over here. If I played this E shape and played the same notes here, or the same shape on the E, I would be playing an E minor shape. What I'd like to be playing is an E Phrygian shape. So how can I convert this shape that I'm already in from the Phrygian to an E minor? You could take that second and shift it forward. So in other words, all the Fs right here, I can shift them forward. And so that'll make a new shape. So instead of visualizing a whole new set of shapes, one way I might start to approach it is to say, well, I know this one shape, I'm just going to tweak the one interval to convert it to whatever the closest other shape that I want is. So that's something to note. And by the way, when you're playing a song, like you might be saying, if I'm going if I'm playing in C major, for example, and then I'm going to the E, I could start to build a chord. If it was just a triad chord, it would just be a minor chord. It would have a minor third. But if I want to build more onto that, you might say, well, now I've got this flat second. Maybe I don't want to have the flat second. Maybe I'm going to convert it as though I'm playing in the minor scale, right? So that means that, how would I do that? Like if I'm going from a C major and I'm going from the 1 to the 3, then when I play the second, if I add that to the chord, you might convert in your mind, you might convert the whole thing to basically a minor chord, or you keep it in the minor mode of the Phrygian mode, which has a distinction than the minor scale of this second, right? The flattened second, which is kind of tensiony sounding. So you may or may not want that. It'll fit, all the notes will fit in the key if you play that one. So what can you do? Like when you do that, you could say, well, either I ignore that note, I don't play it, because if I just played a triad, I wouldn't play it, and it wouldn't matter if I'm in the minor scale or the Phrygian scale, because they're both minor modes and they both have a minor third, and the triad will be the same. Or I can just play the note that I know is in the shape, which would be a flattened note, and that will be chromatically, it'll be in the same, all the notes will be in the same key. I'm just playing another chord in the same key, right? Although it has a flat, so it won't be paralleled the same. It won't be parallel the same if I played a second or a 9 related to the C, and then I change it to the third of the Phrygian. Or I can say, well, I'm going to play a note that's not in the C major scale as I move to the third of the C major scale, because I want to convert to the related minor scale, adding then the Phrygian second, or the minor second, right, related to the minor scale, right? So you could test all of those different things out if you want to noodle around with them. But anyway, we're gonna now go from here to the second. So this minor second represents the second position in the scale. This number 1 represents the distance, which is only 1 note away. Because we're on the second, from a chord construction standpoint, we don't have even numbers. So we go from 1, 3, 5, 7. That's the last note in our scale, or our last position. And instead of going around to 2, we go to 9. So that means that this 2, the second, can also be called a 1 note away minor 9. It's a minor 9. All right. Okay, so let's do this. So if I was to go here, it's just going to be 1 note away. So boom, boom. So right there. So you get that tensiony kind of sound. So we're going to go up 1 string and cross the fault line. We're looking for a 1 note away minor second, which could also be called a 1 note away minor 9th. And when we go above the string, we look for the inverse distance. So we have 1 note away, 12 notes in the alphabet. 12 minus 1 is 11. Therefore, I'm looking for a distance of 11. So if I go up, I'm crossing the fault line. So I have to go this way, -5, -4, 3, 2, 1, 0, or 12. And then 12 minus 1 is 11. Let's go from here. So we have to go diagonal, -5, 4, 3, 2, 1, 0, or 12, and 12 to 11. So from here to here, if I went from top to bottom, you get that tensiony sound, but that is an 11 note away, the inverse, the 11 note away which would be a major 7, remembering that the inverse of a minor is a major. If I measured from the bottom, from the E to the F, from that perspective, that would give us the 1 note away minor second. So the inverse of a 1 note away minor second is an 11 note away major 11. So that means that if I go up one string and cross the fault line, the 1 note away minor second, which could also be called the 1 note away minor 9, is 1, 2, 3, 4, 5 frets forward. But normally I wouldn't cross the fault line. That's the only time I would, because if I was here, I would go to there. If I was above the fault line, I would be going from here, not to there, I'd be going to here. So normally, if I go up one string, the 1 note away minor second or 1 note away minor 9 would be 1, 2, 3, 4, 5, 6 frets forward, which also means it would be 6 frets back. That's right in the middle, unless I cross the fault line, which would only happen on the B string, in which case if I go up one string, the 1 note away minor second, which could also be called the 1 note away minor 9th, would only be 5 frets forward. Okay, so let's go to 2 strings up. So going 2 strings up to here, and we're looking for the 1 note away minor second or 1 note away minor 9, crossing the fault line. So we have to look for an inverse distance. 12 minus 1 is 11. Distance of 11, I have to go back to get to my 5. So negative 5, negative 10, and 11. Let's measure it from here. So here, negative 5, negative 10, and 11. So if I went from top to bottom, that would be that kind of tensiony sound. That would be the 11 note away, which would be a major 7. If I go from bottom to top, therefore, from the E to the F and measure it that way, that's the 1 note away minor second or 1 note away minor 9. Therefore, if I go up 2 strings and cross the fault line, the 1 note away minor second, which could also be called the 1 note away minor 9, is 2 frets back. I wouldn't cross the fault line if I started on the G or the E string and went up 2 strings. So I'm going to go, it would be from here to here. So normally, if I go up 2 strings, the 1 note away minor second, which could also be called the 1 note away minor 9, would only be 1 fret back unless I cross the fault line, which would happen on the B or the E string, in which case if I go up 2 strings and cross the fault line, the 1 note away minor second, which could also be called the 1 note away minor 9, would be 2 frets back. All right, let's go 3 strings up. Try to get in a rhythm here. 3 strings up. So now I'm looking for the 1 note away minor second, 1 note away minor 9th. Up 3 strings, crossing the fault line. I have to look for the inverse distance, therefore, because I'm going above the note that I'm looking for. So 12 minus 1 is 11. Distance of 11 is what I'm looking for. Negative 5, because I crossed the fault line. And then 10, 15. There's only 12 notes in the musical alphabet. 15 minus 12 is 3. And so I'm going to say negative 3, 2, 1, 0, or octave. And then I could also call it 12 minus 1 is 11. So let's count it out from here. So we're going to say, all right, this is going to be negative 5, negative 10, negative 15. 15 minus 12 is negative 3, negative 3, 2, 1, 0, or octave. So 12 minus 1 is 11. So if I went from top to bottom from this F to this E, that would be an 11 note away, which would be a major 7. Bottom to top from the E to the F, therefore, is a 1 note away minor second or 1 note away minor 9. Therefore, if I go up 3 strings and cross the fault line, the 1 note away minor second or 1 note away minor 9 is 3 frets forward. The only time I wouldn't cross the fault line if I went up 3 strings would be on the G string, unless I think about going around the top of the guitar, in which case if I started from like this E, I'd be going to this F, which is just out of sight. Let's move up there, pinch. So normally then, if I go up 3 strings, the 1 note away minor second, which could also be called the 1 note away minor 9, would be 1, 2, 3, 4 frets forward, unless I cross the fault line, in which case, if I go up 3 strings, the 1 note away minor second, which could also be called the 1 note away minor 9, would only be 3 frets forward. All right, let's go to the top one. Noting that the top one because I'm on this bottom string, it would be easier for me to measure the bottom string and then tie it out to the top, meaning it'd be easier for me to look down here most likely and say, okay, if I'm looking for the 1 note away minor second, instead of looking for the inverse distance and counting up to the top string, maybe I find it on the bottom string where I don't have to look for the inverse distance and I can just look for 1 note away. I don't have to deal with the fault line because I'm down here, so I'm just going to say this is going to be 5. And then, so I'm going to say this is going to be 5, 4, 3, 2, 1. And if it's an F down here, it's going to be the same up top because it's the same notes on the string. If I measured it this way, it'd be -5. If I want to go to the top this way, it's going to be -5, -10, -15, 15 minus 12, because there's only 12 notes in the musical alphabet. It's -3. 3 plus another 5 is -8. And -8, 9, 10, 11. Right? We're looking for a distance of 11 because it's the inverse distance when I go above the note. If I count it out this way, it's going to be -5, -10, -15. 15 minus 12 is -3, plus another 5 is 8. So -8, 9, 10, 11. So from here to here, top to bottom, would be a 11 note away, which would be a major 7. Bottom to top would be a 1 note away minor second. So therefore, if I go up 4 strings, which means I'm going to cross the fault line unless I think about going around the top of the guitar, because I can't go up 4 strings and not cross the fault line, then that means that if I go up 4 strings, the 1 note away minor second, which could also be called the 1 note away minor 9, will always be 1, 2, 3, 4 frets back. All right, let's just do the last one, which we kind of touched on. If I go down 1 string, I no longer have to look for the inverse distance. I just need to look for the 1 note away in the 1 note away minor second or 1 note away minor 9. So I could say 5 is right below it because there's no fault line now. So 5, and it's 4, 3, 2, 1. Boom. So if I go down, it's going to be here. 5, 4, 3, 2, 1. Boom. Top to bottom would be a 1 note away minor second or 1 note away minor 9. Therefore, if I go down 1 string, the 1 note away minor second or 1 note away minor 9 would be 1, 2, 3, 4 frets back unless I cross the fault line, which would only happen on the G string. So if I was on this G string, I would cross the fault line and it would be here. So the rule is, if I go down 1 string, the 1 note away minor second, which could also be called the 1 note away minor 9, will be 1, 2, 3, 4 frets back unless I cross the fault line, which only happens on the G string, in which case if I go down 1 string and cross the fault line, the 1 note away minor second, which could also be called the 1 note away minor 9, will only be 3 frets back, 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 baby.